Hi, welcome to the ComSci 137 lecture. Sunny here. For this module, we will be discussing the overview of data communication and networking. Let's start. Shock? Curious? This was actually taken from the Bible, Numbers chapter 23, verse 23. This was the first message sent through the telegraph by Morse, and the world have changed since then. Data communication and networking have improved over the years and have greatly affected our daily lives. Instead of waiting for weeks for a report or document to arrive via snail mail, it can be accessed immediately by a click, even if both sender and receiver are 100 miles apart. Speaking with loved ones across the world is more intimate through video calling. People interact with other people in the world to express themselves through social networking services, and the list goes on. To start, let's define some terms. When we communicate, we share information. This can be done locally via face-to-face or remotely, which takes place over a distance. The term telecommunication, which includes telephony, telegraphy, and television, means communication at a distance. Tele is a Greek word which means far. Data communication is the exchange of data between devices via some form of transmission medium. Data is any information presented in whatever form agreed upon by the parties. For data communication to occur, the communicating devices must be part of a data communication system, a combination of hardware and software. The effectiveness of a data communication system depends on four fundamental characteristics. First, delivery. The system must deliver data to the correct destination. Data must be received by the intended device or user, and only by that device or user. Accuracy. The system must deliver the data accurately. Data that have been altered in transmission and left uncorrected are unusable. Timeliness. The system must deliver data in a timely manner. Data delivered late are useless. In the case of video and audio, timely delivery means delivering data as they are produced, the same order that they are produced, and without significant delay. This kind of delivery is called real-time transmission. Jitter refers to the variation in the packet arrival time. It's the uneven delay in the delivery of audio or video packets. For example, let us assume that the video packets are sent every 30 microseconds. If some of the packets arrive in with a 30 microseconds delay and others with a 40 microseconds delay, an uneven quality in the video is the result. Components of a data communication system. Message. It is the information to be communicated. Sender. It is the device that sends the message. It can be a computer, workstation, telephone handset, video camera, and so on. Receiver. It is the device that receives the message. The transmission medium is the physical path by which a message travels from sender to receiver. Protocol is a set of rules that govern data communications. It represents an agreement between the communicating devices. Information today comes in many different forms. Text is represented as a bit pattern, a sequence of zeros and ones. Different sets of bit patterns have been designed to represent text symbols. The widely used coding system today is the Unicode. It uses 32 bits to represent a symbol or character used in any language. Another is the American Standard Code for Information Interchange or ASCII. It uses 8 bits and constitutes the first 127 characters in Unicode. Numbers are also represented by bit patterns, but they are directly converted to a binary number. Images are also represented by bit patterns. In its simplest form, an image is composed of a matrix of pixels or picture elements where each pixel is a small dot. Audio refers to the recording or broadcasting of sound or music. Audio is by nature different from text, numbers, or images. It is represented by a continuous signal. Video refers to the recording or broadcasting of a picture or movie. Video can either be produced as a continuous entity or it can be a combination of images. Data flow refers to the direction of data. In simplex mode, the communication is unidirectional. as on a one-way street. Only one of the two devices on a link can transmit, the other can only receive. In half-duplex mode, each station can both transmit and receive, but not at the same time. One device is sending, the other can only receive, and vice versa. The half-duplex mode is used in cases where there is no need for communication in both directions at the same time. The entire capacity of the channel can be utilized for each direction. In full duplex mode, both stations can transmit and receive at the same time. The full duplex mode is used when communication in both directions is required all the time. The capacity of the channel, however, must be divided between the two directions. We will now define what a network is. A network is the interconnection of a set of devices capable of communication. Devices can be a host, like large computer, desktop, laptop, mobile phone, or security system. It can also be a connecting device, like a router, which is represented by this image, a switch, represented by this image, or a modem. A network uses distributed processing, which means a task is divided among multiple computers. A network must be able to meet a certain number of criteria. The most important of these are performance, reliability, and security. Performance can be measured in many ways, including transit time and response time. Transit time is the amount of time required for a message to travel from one device to another. Response time is the elapsed time between an inquiry and a response. Performance of a network depends on a number of factors, including the number of users, the type of transmission medium, the capabilities of the connected hardware, and the efficiency of the software. Performance is often evaluated by two networking metrics, throughput and delay. We often need more throughput and less delay. However, these two criteria are often contradictory. If you try to send more data to the network, it may increase throughput, but we increase the delay because of traffic congestion in the network. In addition to the accuracy of delivery, network reliability is measured by the frequency of failure, the time it takes a link to recover from a failure, and the network's robustness in a catastrophe. Network security includes protecting data from unauthorized access, protecting data from damage and development, and implementing policies and procedures for recovery from breaches and data losses. We will now discuss network attributes. A network is two or more devices connected through links. A link is a communications pathway that transfers data from one device to another. For visualization purposes, it is simplest to imagine any link as a line drawn between 2 points. For communication to occur, two devices must be connected in some way to the same link at the same time. There are two possible types of connection, point-to-point and multipoint. A point-to-point connection provides a dedicated link between two devices. The entire capacity of the link is reserved for transmission between those two devices. A multipoint connection is one in which more than two specific devices share a single link. In a multipoint environment, the capacity of the channel is shared either spatially or temporally. If devices can use the link simultaneously, it is a spatially shared connection. If users must take turns, it is a time-shared connection. The term physical topology refers to the way in which a network is laid out physically. Two or more devices connect to a link. Two or more links form a topology. The topology of a network is the geometric representation of the relationship of all the links and linking devices, usually called nodes, one another. There are four basic topologies possible: mesh, star, bus, and ring. In a mesh topology, every device has a dedicated point-to-point link to every other device. The term dedicated means the link carries traffic only between the two devices it connects. To find the number of physical links in a fully connected mesh, we use the formula n times n-1 divided by 2. For example, if we have 5 nodes, we will need 10 links. A mesh offers several advantages over other network topologies. First, the use of dedicated link guarantees that each connection can carry its own data load, thus eliminating the traffic problems that can occur when links must be shared by multiple devices. Second, it is robust. If one link becomes unusable, it does not paralyze the entire system. Next is the advantage of privacy or security. When every message travels along a dedicated line, only the intended recipient sees it. Last, point-to-point links have made fault identification and fault isolation easy. Traffic can be routed to avoid links with suspected problems. The main disadvantage is the high cost. It is related to the amount of cabling and the amount of I/O ports required. One practical example of mesh topology is the connection of telephone regional offices. Here is a sample of mesh. In a star topology, each device has a dedicated point-to-point link only to a central controller called a hub. The devices are not directly linked to one another. Unlike a mesh topology, a star topology does not allow direct traffic between devices. The controller acts as an exchange. For its advantage, it is cheaper than a mesh. In a star, each device needs only one link and one I/O port to connect it to any other devices. It is also easy to install and reconfigure. It is also robust. One big disadvantage is the dependency of the whole topology on one single point, the hub. If the hub goes down, the whole system is dead. Sometimes, it needs more cabling than the other topologies. Here's an example of star. The preceding examples all describe point-to-point connections. Bus topology, on the other hand, is multipoint. One long cable acts as a backbone to link all the devices in a network. Nodes are connected to the bus cable by drop lines and taps. A drop line is a connection running between the device and the main cable. A tap is a connector that either splices it into the main cable or punctures the sheeting of a cable to create a contact with the metallic core. As a signal travels along the backbone, some of its energy is transformed into heat. Therefore, it becomes weaker and weaker as it travels farther and farther. For this reason, there is a limit on the number of taps a bus can support and on the distance between those taps. Advantages is the ease of installation. It also costs less. Disadvantages include difficult reconnection and fault isolation. A bus is usually designed to be optimally efficient at installation. It can therefore be difficult to add new devices. Signal reflection at the taps can cause degradation in quality. In addition, a fault or break in the bus cable stops all transmission. In a ring topology, each device has a dedicated point-to-point connection with only the two devices on either side of it. A signal is passed along the ring in one direction, from device to device, until it reaches its destination. Each device in the ring incorporates a repeater. When a device receives a signal intended for another device, its repeater regenerates the bits and passes them along. A ring is relatively easy to install and reconfigure. Each device is linked to only its immediate neighbors. To add or delete a device requires changing only two connections. In addition, fault isolation is simplified. Generally, in a ring, a signal is circulating at all times. If one device does not receive a signal within a specific period, it can issue an alarm. However, unidirectional traffic can be a disadvantage. In a simple ring, a break in the ring can disable the entire network. This weakness can be solved by using a dual ring or a switch capable of closing the break. Next are the network types. First is the local area network or LAN. LAN interconnects hosts. It is usually privately owned and can be as simple as two PCs and a printer. It is limited to a few kilometers, spanning an office, a building, or campus. Next is the wide area network or WAN. WAN interconnects connecting devices. It is normally created and run by communication companies. It is involved in long-distance transmission of data. Today, it is very rare to see a LAN or WAN in isolation. They are connected to one another. When two or more networks are connected, they make an internetwork or internet. Take note of the small I. An internet is a switch network. Each switch connects at least two links together. A switch needs to forward data from a network to another network when required. The two most common types of switch networks are circuit switch and packet switch networks. We will discuss both later. This is the end of Module 1. Thank you.